So hi everyone, this is the video for my task 10.2D, and in this video I'll be starting from scratch, and I'll be making this video for a user or for a learner who has no experience in embedded system, and I'll be explaining my project from scratch, my libraries, that what libraries I'm using, why I have made like 4 whys, that why I have made this project, what I'm doing in this, when I was doing this, and what I'm actually doing, and why actually we need this project, and how I'm doing all of this, and I'm combining all of this and just making things. I'll be explaining everything in detail. I'll be putting part of this video. So first of all, there will be an introduction video, and then after that I'll be explaining everything about my code, that what code I'm using, what function is doing what things. So I'll be explaining everything from the basic, that actually why do we need this project. So let's start from the problem statement. So first of all, what I'm making a gesture control device. Any ideas what is actually a gesture control device? So for example, if I have a bulb on in front of myself, then I would need it to switch on or off if I'm not able to move, if I have some mobility issues. Especially for the patients who have some mobility issues, or who are not able to just they have some issues to move. So I'm making this for them. My target audience is the people who have some mobility issues and who just can't go and just switch off the bulb from the manual switch. So there is a band, and I have made that band. For example, this is the band. I have made this band, and from this band, if you, for example, what function I have given is, if you tilt it to the right, then the bulb will turn on. If the bulb is already in the state of off, then the bulb will turn on. And if the bulb is on, then if I tilt right, then the bulb will remain on. And if I tilt my hand to left, then the bulb, it will turn off. Simple. I have kept these gestures really simple and really basic, and so that there is no issue for the mobility, for the patient or for the user to understand what they are doing or what they want to do. And the range of it's really long. The range is really long, so you can just be, for example, if you have to switch off the bulb on first floor, then you can be sitting in the ground floor and just tilting your hand to left, and the bulb will turn off. Interesting, right? Yeah, it is. So this is my project, and this is my target audience. Why do I need this? Because people, they just can't, there is a very big audience for this. People, they just can't get up, or the people who are lazy also, they just can't get up and they switch off the bulb. It is a really manageable thing. So through a gesture you can control your home automation, and for home automation I have used a standard bulb, which I have made a smart bulb while connecting it to a motor driver. Now, what is a motor driver? So what I have done is, I have given the code from the nano to the motor driver manually. I have connected those things manually. So I have introduced all the codes in the Arduino about, okay, you know what, let's forget about this. Now I have explained that why I have made this project. So it's for the mobility issues, and actually what I have made, I'll be explaining it now. I'll be explaining all of those things now. And I have explained that why I am making this project. Now I'll be explaining that what actually I have made. So the hardwares that I have used are Arduino Nano. I have used the Arduino Nano. I have used the MPU6050, that is the accelerometer and the gyroscope. I have used the motor driver. I have used a standard 5-volt bulb. I have used Raspberry Pi, and I have used a software for Raspberry Pi, that is my GUI, that is basically helping the user to interface with the hardware. So what I'm basically doing is, I have an Arduino Nano that is connected to the MPU6050. I'll be explaining this on the board. Wait. So basically this is I have actually made a block diagram for this. So what I'm basically doing is, as I was explaining that what I'm actually doing. So there is an Arduino Nano that is 33 IoT, and it is connected with a sensor that is MPU6050, and this sensor is basically giving the readings. First of all, at initial stages, you always have to initialize a sensor to give the basic readings about its surrounding. For example, whenever you have to start a project, I took this sensor and how I actually proceeded. Now actually I'm also covering the topic about how I actually did it, how I initialized. So at first stages, I took my sensor, I initialized it with the basic readings, and when it showed the basic readings about its surroundings, I calibrated the sensor. Now what is calibrating the sensor? Calibrating this sensor means using the sensor according to yourself, that how you want that sensor to work. So what I did was, for this project, if there is a right tilt, then I need the bulb to turn on, and if the bulb is left, then I want the bulb to get off. So that's the gestures, right and off. But what is this center? This is a neutral point that I have introduced in my code. So I have adjusted some threshold values, and in my code, for example, I have adjusted the values as 5000 and -5000. So these are the threshold values. If I'll turn my hand on, then the bulb will turn on, and if I'll turn my hand like this, then the bulb will remain on, because there is a threshold value adjusted. There is a neutral point here, and when I'll go beyond this neutral point and turn my hand to left, then the bulb will turn off. So if I'll turn my hand right, then I'll again turn it right, then the bulb will remain on, and same goes for left. If I'm turning my bulb left, then that's basically improvising the accuracy of my project. So this is the threshold value that I calibrated. After giving the basic readings, I calibrated it to threshold. So that's how I initialized. So my Arduino Nano, it is connected to MQ6050, and these are giving the readings for those threshold values, and I have introduced the motor driver. Now what is a motor driver? Okay, so motor driver is basically controlling my bulb and making this standard bulb a smart bulb. What it is doing is that it controls the voltage of this standard bulb. It is helping to control the voltage of this standard bulb by giving the code from the Nano that if the gesture is on, then the bulb will turn on, and it is controlling the voltage of the standard bulb, that is making it the smart bulb for the gestures. Now this story is getting connected because there is a simple cycle. It is a very simple project. But it is really effective, and I've used all the criteria and all the rubrics that have helped me to match the criteria for high distinction. So this is connected manually. Arduino Nano, it is connected manually, and the code in the code, I'll be explaining the code on the board only. And in the code, the motor driver is connected to the pins. There's the connections. I'll also be explaining the connections also. So, and the connections, and if I turn the bulb, like if I give my hand towards the right, then the bulb will turn on. That is in the code of the Nano. And motor driver simply take those values from the sensor, that if the bulb is turning on, like if the gesture is on the right, then the bulb will turn on. And motor driver controls the voltage that is connected manually to the Nano, and it is taking data from the Nano, and Nano is taking data from the MQ6050. And Nano is no microcontroller, of course. So my motor driver is basically switching on and off the bulb from the information that it is getting from the Nano, and from the Nano the sensor is connected, which is basically calibrated to get the readings in the threshold value, that if the bulb is turned, like if the hand is turned right, then there is a threshold value adjusted at a neutral point, and the bulb will turn on, and at the standard the bulb will remain on, and then the bulb will turn off. So this is how my project actually works, and it is a really simple project. I have not used any rocket science for it. I have just made it as a simple project, and this is my project, but it's really effective. It's a really good cycle that cannot be breaked actually, and it's working 100%. It's working all the time. It's really reliable. So the reliability criteria goes on a check for my side, and so this is my project. And now I'll be explaining the hardware. First of all, before that, I'll be explaining the code for my Nano, and what is the code that I'm using, and after that I'll be explaining the hardware. Thank you. Yeah, so now I'll be moving on to the code. I've explained that what is my project and how it is basically working, the basic working of my project. And now I'll be explaining just for a beginner, like this task demand for this only, like it's saying that you have to make this video for a beginner. So I'll be explaining part by part that what each library actually means and what each library actually includes and what each library is actually doing. And according to that, what I have included in my code that is helping my code to work. I've explained that how is my project working, what is my project, the basic working and the cycle of my project, what all are the all parts that I'm doing and how I am doing it. I have explained why I have done this, and now I'll be explaining how I am doing this with the help of a software. What is my software? That is helping the Arduino as the microcontroller to collect the data from the sensor in order to switch on and off the bulb as per the user convenience. So now I'll be explaining everything about the code on board again. Let's go. So now I'll be explaining about my software. Now this is my software, and I'll be talking about the code. Software is basically about the coding here. The software is also about the GUI, which I'll be explaining earlier. I have separated this video in two parts, in which I'll be first explaining about the Arduino, and then I'll be explaining about the Raspberry Pi, that why I'm using the Raspberry Pi and what is the function of using the Raspberry Pi. So now about the Nano. So in Nano there is a code in the IDE. What is IDE? It is the Arduino IDE that basically has the code, and it is an app that basically helps me to function with the Arduino and with different sensors through a USB port or through Bluetooth. So it's a really good platform to do that. And now about Arduino, I've included three libraries in my code, and the three libraries are first one is about the Wi-Fi.Nina. So Wi-Fi.Nina, Nina, Wi-Fi Nina. What does this basically do? It enables Wi-Fi. It enables the Wi-Fi connection that we need to basically run the code. So Wi-Fi is required for me to connect it to the Raspberry Pi through our IP address. So Wi-Fi.Nina enables the Wi-Fi communication. It is used to connect to a network and establish client-server connection. Functions, it has some functions like, I would say in the code it includes Wi-Fi.begin and Wi-Fi.status. And I'll be explaining about these two functions later on the video while I'll be explaining the all of the code. So this is one library. Another library that I'm using is the Wire. Wire library is used for the I2C communication. And now what is I2C communication? I'll also be explaining about this I2C communication later on the code, because it can be understood, we can understand about I2C communication more in a better way while I'll be explaining about the code. Now right now I'm explaining about the libraries, what are their functions. So again, the library that I've used is the library for my sensor, that is MPU6050. It is a library for interacting with the MPU6050, and it has some functions like initialize and get motion. It has these two functions. So these are the three libraries that I'm using. First is about the sensor, second is about the I2C communication, that is the Wire library, and the third is the Wi-Fi.Nina that I'm using for the IP address for the Raspberry Pi. So these are my three libraries that I'm using, and now I'll be explaining the code in a very basic way, so that any person who knows only the basics about the software, or who don't even know about the Arduino. I've explained about the Arduino, so I think so I was able to explain that what is actually Arduino and what is actually, I'll be explaining about the Raspberry Pi actually, and what is actually my sensor doing, and what is basically my project. And now I'll be explaining my code in a very basic way, so that any person can understand that. Thank you. So here I am explaining everything about my code. So here I before actually mentioned that I am including the three libraries. So these three libraries I have mentioned that what are their workings. So about the communication here. So I was saying that I will be explaining about the communication here. that why I'm using this communication. So wire.h, I'm using it for the I2C communication. I2C communication for what, like, actually what it is communicating with, it is actually communicating with the sensor, the MQ6050 sensor. So furthermore, after these three libraries, I'll be explaining like cons.star. I have used the SSID, and this is the name of my Wi-Fi, this is the password for my Wi-Fi, and this is my IP address, and this is the server port, and these are the things that helps me to, like, this is the this IP address, this helps me to connect it with the Raspberry Pi, that is further connected to a GUI. And now the relay pin, the connection with the relay pin here, it is the connection with the relay pin. And before that I have adjusted the threshold. As I mentioned before, that I have used a threshold, the threshold of the gyroscope. It is a threshold of the gyroscope, and it is adjusted to the y-axis to detect a right tilt gesture, and if the y-axis value exceeds the threshold, then it is considered as a right tilt. And if the threshold of the gyroscope, that is adjusted to the y-axis again, of course, and it is if tilted to the left, then the value, if the value of the sensor is below -5000, then it is considered as a left tilt. And Wi-Fi.client, I have used it because it creates a Wi-Fi client object that allows the Arduino to communicate with the server over the network. So after this, I have used a void setup function, and this is the serial.begin, that is the baud rate. Now what is baud rate? Baud rate is basically the rate by which it is sending messages to the serial monitor. It is the rate by which it is sending the messages to the serial monitor. And after this, I have used Wi-Fi.begin. Wi-Fi.begin initializes the I2C communication. I have used the MPU.initialize, that is included in the MPU6050 library, and this is basically initializing the MPU6050 sensor. And later on, as you can see, I have used the if statement, and it tests if the MPU sensor is connected properly. If it is not connected, then it basically prints a message that the it is in a while loop. As you can see, it is in a while loop. So basically it prints a message that your MPU connection failed, the sensor connection failed. After this, I have used a pin mode. What is a pin mode now? Pin mode, I have used it for the relay pin. The relay pin that I'm using, that is the motor driver that I'm using, that I mentioned that I'm using. The motor driver that I mentioned that I'm using, it is the pin mode for that. And output, it is adjusted to add as per the output pin for the motor driver. And now digital, right, it basically initializes it initially sets the relay pin high, which might mean that it is turning the bulb off depending on how the relay is wired. After this, I have used the serial.begin. It is basically used to connect it to the Wi-Fi, and I have also used a delay for milliseconds. It is in milliseconds actually, so it's half a second. 500 milliseconds, it's half a second. So after this, I have used if.client.connect, and basically it attempts to establish a connection to the server, that is the Raspberry Pi, at the specific IP address and the port. And after that, if it is connected successfully, then it will say connected to the server, and if it is not, then it will say connection failed to server failed. It will basically say that the connection is failed. After this, I've used a void loop function, and it has some axes. So these are the variables that store the accelerometer, AX, AY, and AZ, and it has the gyroscope readings also. So I've used a motion.getMotion, and this basically reads the 6 motion values, 3 for acceleration and 3 for rotational velocity, that is coming from the MPU6050 sensor. And below that, I have used the if statement, and this if statement, sorry about my nose, if the y-axis gyroscope value exceeds the threshold for a right tilt, then the bulb will turn on. And if bulb state, that is I have used it for a not sign, so it will basically show that if the bulb is turned off, then it will just show that function. And I have used this basically for like like for example, I can say like the send to server. It is basically sending the message to the server that is indicating that a right tilt has occurred and the bulb is now turned on, and like same goes for the bulb turning off, and I have used it for a delay. And now further, I have used the void send to server, and this is the last function for my code, which is basically helping me to send the data to the server. And like it has the power to like it has two functions. So first one is client.connect. Basically it checks if the client is still connected to the server. Client.println, it basically sends the message to the server. And else statement is if the client is disconnected, then it will print a message indicating that the connection has been lost, and will basically print disconnected from the server. So this was my whole code for the project that is in the Arduino IDE. Now I'll be explaining about the Raspberry Pi, that what is my Raspberry Pi doing and how it is working with GUI. Thank you. So now I'll be mentioning that why I'm using the Raspberry Pi. So first of all, about the requirement, that why I'm using it, what I'm actually doing, and how I am doing it. So these things are about the Raspberry Pi. So in order to get a higher grade, I have to use Raspberry Pi. And why I'm using it? So Raspberry Pi, it is acting as the server that basically the data that is coming from the Arduino, the readings, it is collecting those things, and it is just taking those things, and it is acting as a server. First of all, it is acting as a server. And in this, for example, if my goal is to create a smart home system that, for example, if I do a hand gesture such as tilting, that is used to control the devices. I have used a light bulb. So the Arduino Nano is equipped with equipped with the sensor and the gyroscope. So the data is processed and transmitted to the Raspberry Pi, which I mentioned is acting as the server. So the Raspberry Pi is essential as it is receiving the data from the Arduino Nano, and it interrupts them, and it relays the information for further action. For example, it is displaying all the data. For example, if the bulb is turned on, then it will display the data on the GUI. I'm using Raspberry Pi for the GUI. So all the data that is coming from the Arduino Nano, the data is being transmitted to the GUI. So now what is the GUI and why do we actually need it? So to basically, in all the home automation systems right now, in the modern automation systems, we do need some verifications. We do need some advanced things. So we can, from this GUI, we can add some voice commands. For example, what I have added is user convenience. What is user convenience in this? There are 2 points. First is about the fault tolerance, and the second thing is about additions. So what is basically Arduino Nano is doing? This was the model. Arduino Nano is basically transmitting all the readings to the Raspberry Pi, and the Raspberry Pi is sending those things to a server, an HTML page basically, where the user can interact through an interface, and all the data will be displayed there. 2 things here now. For user convenience, as I mentioned, fault tolerance. For example, if the Arduino Nano is not working and the bulb is not turning off, then the user can just open the server and turn the button off. They can just click the button of off and the bulb will turn off. So in terms of fault tolerance, this thing is there. If the Arduino Nano is not able to get the readings from the Raspberry Pi, from the sensor, then the server is connected to the bulb through the motor driver, and it can control the bulb through the HTML page. Now additions. We can add, in future, we can add some voice commands. We can add some additional features. We can add some advanced commands. Why do we need this? In the modern era, we need good automation systems, and we need a good working project. We need, the basic thing that we need is reliability. That is the most important thing, because we are targeting the people who have mobility issues or who are differently abled, those who like those people who cannot walk, or those people who have issues to just get up and switch off the bulb or switch on the bulb. We are making this thing for them. And if they need anything emergence, like if they need the thing in it's like, for example, if it is an emergency, then we do need a reliability of what? Every time when we do the right gesture, the bulb should turn on, and whenever we turn the bulb like to the left after the neutral point, the bulb should turn off. It is about the reliability, and it should work 100% every time. So for instance, we cannot say Arduino Nano will be 100% reliable all the time. We'll give the readings to the Raspberry Pi. The Raspberry Pi will take it to the server, which is acting as a HTML page. We have a HTML page as the interface where the user will interact, and through that HTML page, we can switch on and off the bulb. And this is my first feature. Second feature, what I'm saying is, for example, if the user always wants the bulb to turn on at 10 a.m., if the user always gets up at 10 a.m., then he or she can just adjust at that point that yes, every day I wake up at 10 a.m., so automatically the bulb will turn on at the particular time. I have adjusted the IST, the Indian Standard Time, to the server, and the bulb will automatically turn on 10 a.m. each and every single time. So these are the two things that I've added. About the fault tolerance, that it is focusing on the reliability. For example, if the Arduino is not working, it will work. For example, if the Arduino is switched off, then it will work. For example, if the Raspberry Pi is also switched off, then the fault tolerance will also work. Like how it will work? The Raspberry Pi, for example, it is switched off. I have still the convenience from the server, which is connected to the motor driver from the Arduino, and then also we can switch on and off the bulb from the HTML page, from the HTML page. What I want to say is from the interface from which the user is getting the interface of switching on and off the bulb. The user convenience of switching on and off the bulb at a particular time every single day. So these are the two things that I've added, and I hope I was able to explain my project in a really good way. I've explained about the Arduino Nano, the working of it, how it is working, why I'm doing this, what I'm doing this, and how I'm doing this. I've explained why I'm doing this Raspberry Pi, why is it necessary basically, because we do need modern automations. Because without Raspberry Pi, an Arduino without Raspberry Pi will be just basic. Anyone can do it. There will be no convenience for the user. First of all, there will be no reliability for the user, which is really dangerous for the mention that what I have included in this video, this is the closure for the video. So I have included a good introduction that what I am doing, and I hope I was able to explain a normal guy who is seeing this video about my project demo, about my code, each and everything. I'll be going step by step, because I have got a really positive feedback from a tutor, a learning thing, that I should just be very systematic with my videos. I should just make my videos in a very good concept way, that I should know what I'm speaking at some particular points. I should be clear with my things, and I should be managing things in the right way, in the right order, so that my video, it doesn't feel like it's cluttered. It should be in a systematic way. So the things that I've included is, I've explained each and everything that I've explained. I've worked on 4 criteria: why, what, when, and how. Not on when that much, but why, what, and how. How I'm doing this, why I'm doing this, and like why have I done this, why is it necessary. I've explained everything. I've explained everything about the working. I've explained all the cycles. I've explained why I'm using Arduino Nano, what is the sensor, how is it working, and I've given my 100% effort in giving the basic things, the basic criteria, that like the basic things in a very basic way. I have explained everything. So I think so I was able to explain everything, including the code also. What is the code, why I'm using it, and how is it basically working, each and everything, each and every library, how is it working, what are the functions that are included in it. So I've explained about the Raspberry Pi. Moving forward, later in the video, I've explained about the Raspberry Pi, that I have used the Raspberry Pi, when I'm using Raspberry Pi, and like how is it working, why is it necessary, and like I've explained everything about it, what is it doing. So everything in this project is necessary and I cannot take anything out of this project. This project is a complete learning thing for me, and I hope I made this video for someone who can learn from this video and can learn about embedded systems. Thank you so much.